802.11 medium access control. Upon completion of this course, you'll be able to describe the 802.11 medium access control, okay, the MAC mechanism. Analyze the WLAN media access process. Content number 1, the MAC mechanism. So the carrier sends multiple access coliseum detection, for short we call as a CSMA-CD. So it's a mechanism of the coliseum detection and avoidance. It prevents the multiple devices from hitting the line at the same time. Okay, just happening for those of the half duplex device. Okay, when they want to using the same doing the same transmission, okay, at the same time. So to prevent the collision happen in this kind of the half duplex machine, so they require the CSMA-CD to prevent the collision. So this is the most common happening on those of the LAN connection. The working process of CSMA-CD. The terminal detects whether the line is idle. So it will go to check. If the line is no idle, then you're going to keep repeat and scanning again. Okay, so all the SDA have to wait until the line is idle before they can send out the frame. Only when the line is idle, then the next one they're going to detect is there have any collision happening on the current traffic, the network. If yes, they will also on hold the frame first. It will not going to send out until it's confirmed that the traffic is idle and there's no collision. Yes, then we can send out the frame. So the CSMA-CA will be used for the 802.11. Okay, just now the CSMA-CD is used for the 802.3, which is the Ethernet LAN connections. For the wireless, it's using CA. So this is the name for the CSMA-CA, the collision avoidance. So the working mechanism. So right here, giving the example come from 4 different stations, our PC. Okay, we have the station number 1, 2, 3, and 4. So each station we're going to generate the different back-off window. In another word, this back-off window will also give you the priority. Who can actually send the frame first? Because our wireless, the AP is belong to the half duplex device, so it can't able to allow every station to send the frame at the same time. So they have to queue for forwarding the frame. So now all the station they have its own back-off window. So station number 1 is 10, station number 2 is 9, followed by 3 is 3, station 4 is using 5. So right now, who have the shortest back-off window, then which station can allow to forward first? So we just assume this one is the time in seconds. Okay, after 3 seconds, then the station 3 can able to forward the frame. Okay, after 3 seconds, so now it becomes 0. So when the station 3 becomes 0, so the 10 also will become number 7, okay, because it's already past 3 seconds. The 9 after past 3 seconds remaining 6, and then the 5 remaining 2 seconds. So right now I already forward finished my entire frame. Okay, now I need to generate another new back-off window. So every time after I finish my the data transmission, the station is required to generate another new random back-off windows. So now the new one, okay, this is the new one. Back-off window size is 9. So now check again, 7, 6, 9, and 2. So now we will notice the station number 4 have the highest priority can forward. Okay, after 2 seconds, station 4 can forward the frame. So this one will become 0. After 2 seconds is passed. So 7 will become 5. 6 will become 4. 9 will become 7. And I just finished forward all my frame. And I'm going to generate another new number. My new back window is 11. So they follow by this way, take turn and queuing for doing the data transmission. So this is called a bell window. So the next one, hidden node. Two devices on wireless network may not be able to communicate with each other. A hidden node is within the communication range of the AP, but cannot communicate with the other signal receiver of the same AP. So right now, we understand each laptop, they have this on BSA. So the PC number 1 have its own coverage area. I only can scan the area surrounding me only. In my surrounding, I only detect AP. Same happening to the PC number 2. Inside the PC number 2 BSA, this is my coverage area. I only can scan one AP in this area. So now the PC1 and PC2 can't able to see each other. Then how they actually can prevent the collision happen? Because just now the bell window is only happening when all the station can able to scan each other. So they can able to compare the bell window and queue. So like example right now I have the bell window. My bell window is 7. Okay, and PC number 2 bell window is maybe using number 9. So by right, the PC7 will have the highest priority can forward the frame. But the problem is what? Because I can't able to deliver my control frame to inform the PC number 2. Because this is my maximum range. Okay, can't able to reach to a PC2. Same to the PC on the other side. So that's why they thought, okay, when I have no one can occupy the channel with me, that means I have no challenger. So I can always forward the frame to the AP without waiting the queue. Same happening to the PC2. So at this moment, these two PC trying to forward the frame, then the collision will be happen. So this is what we call the hidden node. To prevent this happening, so we can actually using the RTS and the CTS. A device can send the RTS CTS frame to reserve the transmission channel before sending the data frame. So every single PC, they will always sending the RTS to the AP because they need to know, am I allowed to send the frame first? So PC1 will send the RTS to the AP, and the PC2 will also send the RTS to the PC. To the AP here. Okay, so inside my RTS will consist of my priority. Like example, just now I did mention, I am 7, and my bell window is number 9. So this information will be delivered to the AP. Then the AP will going to check. Okay, right now you have the highest priority. Now I'm going to send both of you the CTS, clear to send. So clear to send will be sent to the PC1 and also the PC2. So right here the CTS will carry the information of the PC number 1. So the PC2 will understand right now I have no priority to forward the frame. I have to wait because in another side of the AP they have some other user access. So I have to wait the other user finish the frame forwarding, then I can forward my frame. Okay, so this is the RTS and the CTS. Then the next one, the exposed node. An exposed node is within the communication range of the transmitter, but out of the communication range of the receiver. Exposed node. So right now, PC1 and PC2 can able to scan each other because the PC2 is inside the PC1 range. Same, the PC1 also inside the PC2 scanning range. So in my range, I can detect PC number 1. PC number 1 also can detect the PC number 2. So both of them, they have no problem. Okay, now what's the big problem right here? Right now, my PC1 have the back of window number 7. My PC2, the back of window is number 9. So they will thought, since right now you have the smaller back of window than me, I will let you forward the frame first. But I didn't know the PC1 actually is connected to the AP number 1. is different AP than the PC number 2. So basically for the PC number 2 can forward the frame without queuing, okay, because there's nobody connected to the AP number 2. Okay, there's no need to deal with the PC number 1. So this is called the exponent problem. With using the RTS and CDS can solve this problem as well. So a device can send the RTS CDS frame to prevent the collision before sending the data frame. So like this one. How to make the PC2 know I connect to another AP? So we understand our SDA will periodically send the RTS. So this RTS is not only received by the AP, at the same time, PC2 will receive. Okay, because the PC2 inside my CoverEdge, this is my BSA, so PC will receive as well. So when the PC2 open the RTS here, they know. Now I understand the PC number 1, even the back window for him is 7, but he connect to the AP number 1. It's different than my AP here, right here. So since I receive his RTS, I no need to wait for this transmission anymore. I can just straight away forward my frame through my AP. Okay, the RTS and CTS. Okay, so this one is my the wireless card, the properties. Right, so now I'm entering to this wireless network card. So I go to the configure and I will select the advanced. So from this advanced here, okay, in these places, the mixed mode protection. Okay, the mixed mode protection inside our PC. So you notice they have the RTS and the CTS. So they have two modes for us to select. Okay, CTS to self-enable or the RTS, CTS enable for both. So this is happening to which one that you're going to select. Of course, the RTS and CTS, after we enable, we can able to prevent the exposed node and the hidden node problem. So we always will have the better the Wi-Fi connections, okay, without the packet drop, or we wait for so long before we can access to the network. But in a chance, they will consume a lot of the power. All right, they will use a lot of the power. For the CTS can help you to save a little bit, but the CTS to self-enable is only happening. They can help you to prevent the hidden node problem, okay, which is not the exposed node. Okay, this one you have to take note when you configure this one. Okay, then the next one, the interframe space. So we have the SIFS, PIFS, and also the DIFS. So they have the different waiting time and the priority. Of course, the shortest waiting time have the highest priority. So let's look at this. The RTS CTS with the CSMA CA. So our SDA, we're going to send the RTS. Okay, our PC sending the RTS to the AP. So after the AP compare with all the PC RTS, and you notice my PC have the highest priority. So after he wait for the this is the time SIFS. So the AP will send the CTS to every single PC. Now my PC after receive the CTS mean I am clear to send. So now I can forward my frame. So after the frame is fully delivered to the AP, then now the AP will going to forward the acknowledge to inform our PC that the AP already fully received all the frame. Okay, so below here you notice there is the NAV RTS. So this one is only happening when the AP receive the RTS. So once I already received the RTS frame and I confirm this user has the highest priority. So at this period of moment, I'm going to block the channel. So that means this channel are not going to receive any more RTS. Okay, even have another new PC joining to the network, and he tried to send me the RTS, I will just reject. Okay, the AP will not going to receive any RTS. And then the next one, the NAV for CTS. This one is only happening after the AP forward the CTS. So after the CTS is already broadcast for all the connected PC. So it will not going to receive or send any CTS. Okay, after everything is complete, then they wait for the DIFS timer. Then they repeat again the step from here. Number 2, WLAN media access. Wireless access process. So the picture here showing there's one SDA and one AP. Wireless user perform the following operation: scan for wireless service, pass the authentication, associate with the AP, and access the WLAN. So this is the standard process for all the SDA. Okay, they have to go through. So the first process can either using the beacon or the probe request response. Okay, the beacon frame will be sent by the AP. The probe request is sent by our SDA. So this one is just for the scanning. Once we get the SSID, then now we create, and if we want to try to associate with the AP, but before associate, you have to done the authentication. Okay, you have to give the username and the password, depend on the security profile, how to set up. Then once already passed the authentication, now finally can associate with the AP. So the scanning mode. A wireless client obtains wireless network information in two ways. So we have the active scan and also the passive. Active scan. The PC will periodically broadcast the probe request, okay, to the surrounding. As long as in my BSA, my on coverage area, when there's any AP can provide the wireless services, they have the SSID. So the AP will going to reply with my message, okay, to send the probe response. So this is the reason why we can able to check the SSID in our device. Okay, you can see so many SSID in the different channel because your device, once you turn on the Wi-Fi, so it will practically send a probe request. Okay, they will keep sending non-stop. And the difference between here, the passive scan. So the passive scan, basically our SDA do nothing. Okay, so only the AP will keep broadcasting. So the AP will keep broadcasting the frame. It's called beacon. So they include the information of the SSID and also the channel of this SSID. So they're going to inform the surrounding, hey, everyone who within my coverage area. So this is my SSID, and this is SSID is belong to the channel number 1 or maybe channel number 6. Okay, so this is a beacon frame. Authentication. So to ensure the wireless network security, AP authenticates SDAs. Only authenticate SDA can be associated with the AP. So now we already passed through the scanning, and now the second step, the SDA have to pass the authentication, or else they can't associate with the AP. And the last one, association. So the client association is a link negotiation process. After 802.11 link authentication is complete, the WLAN client initiates 802.11 link negotiation. Okay, during the link negotiation, the association or re-association packet are exchanged between the client and the server. Okay, after SDA and also the AP form the connection. So right now, the AP will just become like the hub. So everything is sent by the PC, right? You just can directly send to the gateway or send back to the controller. Data frame forwarding. So right now the figure showing the example how our PC is forwarding and connecting to the network. So the first step here, the process, I need to send the data to the AP. PC number 2, they also want to send the data to the AP. So right now they can able to detect each other because they both at the same BSA. So PC number 1, we're going to random generate the bit of time. So my bit of time, PC 1 is 12. PC 2, after they generate, the bit of time is 28. So now, the PC 1 have a short bit of time and can be transmit the data in at once. So now, the PC 1 going to transmit the data and you need to reserve the channel for the duration of 20. So right now I know it's my time to forward the frame, but I also want the AP to receive the channel for me. So this one will be based on the frame. What kind of frame that you're using? Okay, if this frame is required the longest period of time to finish, okay, then they're going to inform to the AP as well. So they inform the AP, I require 20 for me to transmit the entire frame. So the calculate formula will be look like this. The time for sending the data plus 1 SIFS and the time for receive the acknowledge. So the previous one, the timer for the PC 1 here is using, if I'm not mistaken, so should be 12 for the back of window. And this one is actually 28. Okay, so after 12, okay, I assume this is a second, okay, becomes 0. Okay, it's already become the 0. So this one also will become 16. Okay, now 16. I have to wait for 16 seconds before until my turn. So now I already become a 0. I'm going to inform to the AP, I want to reserve for another 20 seconds for me to forward the entire frame. Okay, so 20 seconds for me forward the frame, and plus when the AP fully receive my frame, and the AP also will need to send me the acknowledge, depend on how the size of the frame that we're sending out. So right now the acknowledge also have its own timer. Example, the time is just like 1 second. Okay, it should be very short. But anyway, this is just an example. Okay, this process will be very fast, all happening in the millisecond or nanosecond. Okay, it's not in a second, but I just want to make it simplified to understand. So now become 20 plus 1. So the total time required is 20. Okay, 20 plus 1. So now, my back window requires me to wait for 16 seconds. Now, I need to wait for additional 20 plus the acknowledge. Okay, the time of the acknowledge. So that's why they'll become total of 36 plus the acknowledge. Okay, because right here they didn't mention what's the time for the acknowledge, so they just write down 36. And then the PC2 continue countdown. Okay, countdown until the PC1 finish to forward the entire frame. Okay, now the AP, I have received the data frame, but I have to wait for the SIF to send the acknowledge. So now the AP forward the acknowledge to the PC number 1. So now PC number 1 received the acknowledge frame. So the data is already confirmed and received by the AP. Now they need to generate another new bit of time. Okay, before everyone have to wait for the DIFS before they send the next RTS. So now they know the AP already sent the acknowledge, because this acknowledge is something like the broadcast. So everyone at the same BSA will understand. Okay, they know. Okay, right now the AP finally sent the acknowledge. So now the PC2 will continue doing the countdown. okay, until 0, then it's my turn to forward the frame to the AP, and I will inform to the AP how long I need to occupy the channel. Okay, they just keep repeating the entire process. So summary, 802.11 MAC mechanism. And the next one is the WLAN access process, how they actually perform the process in the CSMA CA.